Let's take a look at a preview feature in Power BI called Visual Calculations. Visual calculations are defined and executed directly on a visual. This makes it easier to create calculations. It makes your calculations easier to maintain, and it also provides increased performance. Now, how does all this work? First, visual calculations can refer to any data in a visual. That data can take the form of columns, measures, and other visual calculations. This removes the complexity of the semantic model. So if the semantic model isn't one of your strong suits, this is definitely going to help you. To truly appreciate the simplicity of visual calculations over traditional measures, take a look at this measure. This measure will display the value of a previous month compared to the current month, or say the previous year compared to the current year. But what if you could turn all of this into this? One of the aims of visual calculations is to greatly simplify the writing of DAX formulas. This lowers the barrier of entry for a lot of people into Power BI because they find DAX to be very intimidating. Now, here are the differences between a visual calculation and a standard measure-based calculation. Visual calculations are stored in the visual, not in the model. This combines the simplicity of a calculated column's context with on-demand measures. Visual calculations operate on an aggregate of the data, not the detail of the data. And it's because of this operating at the aggregate level that the potential for performance benefits increases dramatically. If you're new to visual calculations and want to get the benefit immediately, there are a whole series of templates that have been created that already have the formulas written. This way you could plug in a template formula and just fill in the arguments. The interface for visual calculations is made up of 3 parts. First is the visual preview that shows the visual you're currently working on. Second is the formula bar where you add and edit visual calculations. And third is the visual matrix. This shows the data in the visual, including the visual's calculations. When it comes to formatting the values in your visuals, you can use the standard formatting controls available in the ribbon. But if you'd like additional flexibility, you can visit the formatting section of the visual, go into the properties category, and then in the data format subcategory, you'll pick the particular column or element within that visual and then get access to all of its formatting controls. Be sure to download the files from the link in the video description so you can follow along and do all of this with me. It's the best way to learn, and also have the slide documentation I just went through. The solution files also included if you just want to go in and reverse engineer this. For our first demonstration, we have a simple bar chart that shows the total cost and total sales for 5 regions. Suppose I only want to see the total sales and the profit for each of those regions. Now I could go out and create a profit measure and add that to my data model, thereby increasing the complexity of the data model. Or if this is the only visual I want to tell that story, I can build the calculation directly into this visual. So I'll click on this bar chart, and in the home ribbon, I'll go up and choose New Visual Calculation. Here are the templates that I referred to earlier. Now, since I don't want to choose any of these templates, I'm going to build my own custom visual calculation. We'll look at some of these templates later. So I'll start with Custom. This opens the Visual Calculations window. I can see my visualization above, so I can get an idea of how this is going to look. But in the formula bar, I'll rename this formula to Profit. Now, profit is simply the sales minus the cost. So do square bracket sales minus square bracket cost. I'll hit enter, and we now have this new profit column calculation. Now here's an interesting little party trick. Suppose I only wanted to show the sales and the profit. I need cost in the visual, but I don't have to show it. So over here in the x-axis section, I can click the hide button for cost and remove its visibility state. It's still in the visual, just not visible. Now here's another party trick for you. When you hover over a data bar, in this case a sales for the Midwest, the tooltip will show the sales for the Midwest. If I hover over a profit bar, I'll see the profit for Midwest. But what if I want to see the sale and the cost, or the cost and the profit? Instead of hiding the cost, I can just move it into the tooltips field well. I'll need to restore its visibility, but notice we don't see that bar in the visual, but if we hover over a bar, now I'll see the region, the sale, and the cost. If I hover over a profit, I'll see the region, the profit, and the cost. So don't think you have to lose that information entirely just because you don't display it in the visual. You could display it in the tooltip. Now to get out of this visual calculation edit mode, in the upper left we'll click back to report. And now we're back in the normal view. If you need to return to the editing of that visual calculation, in the build panel next to the visual calculation, you can click the little pencil icon. This will return you to the edit mode. Now let's use visual calculations in a matrix. My matrix is currently broken down by department name, year, then quarter, and I'm using a total sales measure just to calculate the total sales. If I want to see the change of quarter from previous quarter or year from previous year, I'll go up to New Visual Calculation, and we'll use one of the built-in templates, versus previous. There's also a versus next, versus first, or versus last. This will put me into the Visual Calculation Editor and give me a template. The first thing I'm going to do is change the name of this from versus previous to delta previous. Notice that the template gives me nice drop downs to pick from either fields or other calculation elements. So in this case, I want to take the total sales and compare it to the previous total sales. I'll hit enter, and there's my difference in sales from quarter to quarter or year to year. We'll go back to the report. We can now see the difference in sales from one quarter to the next. Did our sales go up? Did our sales go down? Since this matrix contains several levels in the hierarchy, department name, year, quarter, if I were to back up to the yearly level, we can see the difference from year over year. If we were to back up at the department level, we can see the difference from department to department. This probably wouldn't be very practical. So year is probably the lowest level you'd want to drill down. Let's add a few more calculations. Suppose I want to see the percentage of total sales relative to all elements in the matrix. I'll go to New Visual Calculation, and I'll choose percentage of grand total. This gives me my template. I'm going to replace the name of this to percentage of all sales. In our divide function for the numerator, I'm going to choose total sales. But for the denominator, I'm also going to choose total sales. But what do I want to enumerate over? I want to enumerate over every row in this matrix. So for the axis, I'll choose rows. Hit enter, and now we have the percentage of all sales. That could use some formatting. So remember, if I go over to my Format panel, under Properties, Data Format, I'll choose this percentage of all sales column, set that to a decimal number, and use it as a percentage. Returning back to the report, if we're drilled down to the yearly level, we can see that 2018 in automotive made up 4.07% of all sales, all years, all departments. Automotive made up 12.71% of all sales, all departments. And we could collapse our hierarchy and see that a little more easily. What if we wanted the percentage to be based on the department? So in other words, all years should add up to 100% for that department. We'll go to New Visual Calculation, percentage of parent. We'll rename this to percentage of department sales, and our divide function for the numerator will use total sales. For the denominator, we'll also use total sales. But for the axis, we don't want to iterate over every row in the matrix. We want to iterate over each row for the respective column. In other words, for the respective department/year combination. I'll hit enter. Back to my normal report. I'll go to Format, Properties, Data Format. I'll select my percentage of department sales column, set it as a decimal, and express it as a percentage. We can now see within each department, all years add up to 100%, but that department, in the case of automotive, is 12.71% of all sales, because all sales is the parent for each department. Another visual calculation template that's going to be very popular is for creating running totals. So suppose I want to get the running total for every element in the matrix, or have it reset when it changes to a new department, or reset when it changes to a new year. Let's start with the running total for everything. We'll go to New Visual Calculation, Running Sum. The field for the running sum is going to be the total sales measure. I'll rename this to Run All. Hit check. If we go back to the normal report, as we scan down this Running All column, the number never decreases. In fact, by the time we get to the very bottom, the running total for the quarter, the year, the department, and the entire matrix are all the same. So this running total value was never reset. Let's see how we could have it reset every time we change to a new department. We'll start a new visual calculation, Running Sum, change the name to Running Department. The field we're exercising the running total on is the total sales measure. But if we add a comma, we can see there are some additional options: axis, order by, blanks, and reset. The only one we're interested in for the moment is when to reset. So we'll have to skip 3 of those arguments. So when I add my comma, I don't want to pick anything for axis, comma, I don't want to pick anything for order by, comma, and I don't want to pick anything for blanks, comma. But I do want to reset every time I change from department to department. We can enter a value here that indicates the level in the hierarchy at which the reset will occur. Since the departments are at the first level in the hierarchy, we'll type in a 1. Hit check. If we return to the normal report, we can see that every quarter accumulates just like it did in the running all section. But the moment we switch to electronics, the run all calculation did not stop its running total, but the running department calculation reset. That running department will increase until we get to the next category, holiday specials. At this point, we've reached 56,000 for everything, but we've reset to 1,700 for this department. Now let's see how we could reset this every time we hit a new year. We'll start a new visual calculation, running sum. We'll change the name to running year. Our base field is the total sales measure, comma, we don't want the axis, comma, we don't want the order by, comma, we don't want the blanks. But we do want to reset every time we change years, and years is at the second level in the hierarchy. We'll give it a check. Back to the normal report. You can see in 2017 there was only one quarter, 1900. The running year is 1900. For the next year, the run all and the run departments do not reset, but the year does. So 4,200 for the first quarter, 4,200 for the running year. Every time we change to a new year, we get a reset in that running year value. One of the visual issues with these calculations is that if we look at something like the change from previous, this makes sense when you're comparing quarter by quarter or year by year, but it wouldn't make any sense to take automotive and have electronics be compared to automotive, and then have holiday specials compared to electronics. Another issue is for the running totals, like running all and running department. Since running all never resets, the subtotals at each yearly level always match the last quarter, and the subtotal for the department level always matches the last year. Likewise for the running department column. So how can we eliminate this repetition of calculations and have the change from department to department not occur? Let's go back to our change from previous calculation. We're going to wrap this entire function inside of an if function. And the test is we want to check to see if we're working at a yearly level. And if we are, we'll do the calculation. But if we're not, like if we're at a department level, we don't want to do the calculation. So we're going to use a function called isAtLevel. And the level we want to see where we're at is the year level. Close parentheses, comma, that's our test for the if. Let's go to the end of the function, add another close parentheses for the if statement, give it a check, return to the normal report. So we can see that the delta previous is constantly calculating quarter over quarter, year over year, but when we get to the end of that department, no calculation. Start the next department, calculations reset, and at the end of that department, no comparative calculation to the previous department. We'll use this same trick for the running all and running department calculations. So I'll go to the running all calculation, we'll wrap this inside of an if function, and then use the isAtLevel function. We want to see when we're changing year over year. Close parentheses for the isAtLevel, comma. Here's what we'll do if we are at the yearly level. Nothing if we're not. Close parentheses for the if. Hit check. Now before we examine this, let's do the running department calculation. We'll do the same thing. Preface this inside of an if function. isAtLevel, and the level we want is year. Close parentheses, comma. Close parentheses for the if. Let's go back to the main report. As we scroll down, notice when we change departments, we don't see the total for the entire department. Looking at the next department, we don't see the total for the entire department. Let's now look at some customizations when working with change over month. We'll start with a visual calculation that just uses the versus previous template. We'll rename it to delta previous. We'll take the total sales field and deduct it from the previous total sales field. Hit check. Now switching back to the main report, we've got two oddities here. One is we don't need to see the grand total repeated for both columns. We already have it in the total sales. We don't need it in the delta previous column. And since January has no previous, it's 100% change, which doesn't make any sense either. So I want to suppress the total for delta previous and suppress the entry for January. Now we already saw how to suppress the total. Let's implement that. I'll start a new calculation versus previous. We'll call this delta previous no total. We'll take the total sales and subtract the previous total sales. But we want to make sure we don't do that if we're at the grand total level. So we'll wrap this inside of an if function. We'll use the isAtLevel function and use the month name as our target. Close parentheses for isAtLevel, comma for the test, close parentheses at the end for the if. Give it a check. If I scroll down, we can see there is no grand total. But if we scroll up, it's still showing the delta change for January. So how could I get rid of that? Let's go start a new calculation versus previous. We'll call this delta previous no start. We'll take total sales minus the previous total sales just like before. But this one will wrap inside of an if function that will test to see if the previous total sales is not blank. Because if it is blank, I don't want to do the subtraction. Well, January has no previous total sales, which would technically be blank. Now, we don't have a function to test if it's not blank, but we do have a test to see if it is, and we can just flip it. So we'll use a not operator on an is blank function. And we're looking to see if the previous total sales is not blank. Close parentheses for the previous, close parentheses for the is blank, comma, that's our test for the if, final close parentheses for the if. Hit check. Notice in this column, January does not get a delta calculation. And if we scroll down, we don't get a total either. So this if not is blank took care of both problems. If we were to delete the original previous calculation and the original previous with no total calculation, I'll rename this to delta previous. Back at the main report, we have our finished product. Our last example will demonstrate two things. One is that you're not locked into these templates. You can use any DAX function you want to do anything that you want. Just understand it's only going to apply to this one visual. But also, let's see how we could create a ranking system. So within each department, I have this sorted by sales, and I want to show that Ellen was the number 1 seller and Sue was the number 5 seller. So I want a ranking column of 1 to 5, and I want that for each of these departments. Now, these departments have the same people in them, so we're going to end up creating a ranking of 1 to 5, 1 to 5, 1 to 5 for each department, but that doesn't have to be the case. There could be different numbers of people for each department, and the ranking structure would be assigned accordingly. So to create this index column, we'll go to New Visual Calculation, Custom, and let's just start with a RANKX function. So I'll call this index, and if we use a RANKX function, we want to rank each representative against all representatives. So we'll have to use an all function to remove any representative filter. Close parentheses for the all, comma, the expression. We'll rank this against total sales, comma for the value. And for the order, we'll do this in descending order. So highest number is 1, lowest number is whatever. Close parentheses, hit enter, and we'll go over to Format, Properties, Data Format, choose our new index column, and we'll set it as a whole number. Back into the build section, I'm going to move my index column above my total sales column. Now back in the main report, we can see our little 1 to 5, 1 to 5, 1 to 5 list. But notice each department ranks number 1 within its own department. Well, that doesn't make any sense. I don't want to show those ones. So what we'll do is we'll run a little test and says, hey, if we're at the representative level, do this calculation. But if we're not at the representative level, don't do the calculation. So we'll go back to our edit. Inside our index function, we'll wrap this RANKX inside of an if function. And we'll use the ever-famous isAtLevel function. And we just want to know if we're at the level of representative. Close parentheses, comma, there's our test. If we are, do the RANKX. If we're not, don't do anything. Close parentheses for the if, enter, back to the main report. And notice we've removed the ranking for each of the departments within themselves. And that's how we can create a ranking column. So there's our demonstration on using visual calculations. If you're new to this, hopefully this will give you some light at the end of the proverbial DAX tunnel and remove that barrier to entry that makes DAX so complicated. If you want to learn more about visual calculations, I suggest you consult the official Microsoft documentation or the myriad of other YouTube videos out there on this topic. Don't forget to download the files from the link in the video description. And as always, let me know what you think in the comments. Do you think this makes writing DAX formulas easier? Or if you're an expert at creating DAX formulas, do you see this as a giant cop-out? Thank you for watching, and remember at BCTI, the learning never stops.